The lighter your bike frame is, the faster you're going to be in the race. What we try to do is get the frame just as light as possible, but at the same time, we don't want it to be too flimsy.
They want the bikes to be as light as possible, yet as strong as possible.
My name is Nico Henderson. I am an engineer here in the test lab, and this facility is Easton Sports in Van Nuys, California.
We test bats, we test hockey sticks, we test bikes, basically all the products that Easton Sports manufactures, we test them here.
We're always developing new frame designs. We take that design and we take a look at what it can endure on this test. We go back and we make some improvements and come back and try it again.
What we're trying to do is make sure that that bike is safe enough for them to ride for a long period of time, for years.
Now this is what we call a fatigue test. What we're looking at is a bicycle frame. In that direction would be the front wheel. And right here is where the rear wheel would mount. This is where you'd normally put the cranks and the pedals. This is where you'd place your feet. You can kind of look at this and imagine the similarity between actually cranking a bicycle crank all the way around. This is basically doing the same thing. We apply 292 pounds on a pedal. We have these hydraulics here, and that's applying about 292 pounds. And we do that back and forth on each one. Now, the rider wouldn't normally put this kind of load on the bike. It'd be hard to put, 292 pounds on a bike with your leg. You get tired out really quick. So, in a sense, it's sort of an accelerated test.
Our fatigue test runs about 21 hours, which means it's gone 150,000 cycles with no failures.
A cycle is something that repeats. You start here, you go in a cycle, and you get back to the same place. The standard says that if you can get to 100,000 cycles, you're basically okay. They consider that to be a safe bicycle. Now, we sort of go a little bit beyond that, and we try to see if we can get to 150,000 cycles. You can see that the loading is quite severe, and some of them will sort of break in this area where the load's being applied. If we find some sort of crack in the frame before we get to our goal, then we can reevaluate the design and see if we can eliminate that potential weak link. If this frame breaks at, for example, 75,000 cycles, it didn't make it. We would take that data and compare it back to other frames. So we compare all these different frame models, and we can tell which designs are more durable. And we can sort of base our design on that data right there.
Everything that we do involves math in some sense. We're measuring deflections, we're measuring angles, measuring applied stress. We're using algebra to reduce all of our raw data into a meaningful form. If someone wanted to get a job in this arena, I would recommend that, first of all, that they have an interest in sports and that they also have an interest in math and science. It all comes right down to it in the design and in the testing. It's what makes this job interesting and challenging. It's all about math and science.